All right, students, today we are continuing our unit on transformations, and today we're going to be learning a topic of composition of transformations, which is kind of like a combination of different transformations. First of all, we have a specific composition transformation called a glide reflection. A glide reflection is when you start off with a figure and you translate it and then you reflect it. So it's gliding and then reflecting. So from here to here we call it a glide reflection. So to define it, we're going to say it is a combined transformation where a figure is translated first and then reflected. Okay, the next one says composition of transformations, and that is exactly what it sounds like. It's when two or more transformations are combined to form a single transformation. Okay, so here I have a picture of a triangle that is being reflected and then it's being reflected again. So because there's two reflections, this is a composition of transformation. So to go from here to here, we call from here to here, it's a composition of two reflections. All right, so next, composition theorem. It says that the composition of two or more isometries is an isometry, meaning that even just because you're doing two transformations, it's still going to mean that the triangle or the shape, whatever shape it is still going to be congruent to the original. All right, the next one, reflections in parallel lines theorem. If lines K and M are parallel, lines K and M are parallel, then a reflection in line K, so if I have this segment right here and I reflect it over line K, followed by a reflection in line M, so followed by another reflection, take a look at what happens from QP to Q double prime, P double prime. So notice how it's tilting the same way and it's just kind of shifting over. So this, if we describe this as a single transformation, we know that it's two, a reflection and a reflection. But if we describe it as a single transformation, it would be a translation because it's just sliding over. So we call it, it's the same as a translation. All right, and then P double prime is the image of P, and P double prime, the segment from P to P double prime, is perpendicular to both K and M. These are facts that we know. And then here, P double prime is the image of P. Then P double prime, this segment here, is going to be 2D, where D is the distance between K and M. Okay, so here, reflections in parallel lines theorem. If lines K and M intersect at a point, so line K is here and line M is here. So they're just intersecting right here. It says at a point P. Then a reflection in K followed by a reflection in M is the same as A. Okay, so if you look here, I start off with AB, and I reflect it, and then I reflect it again. So really, it's just turning from here over to here. So if this is from here to here is X, and then from here to here is X degrees, that makes this from here way over to here 2X degrees. Okay, so one more time. If I'm going to reflect it, this is also considered a rotation of a certain number of degrees. So from here to here, let's say that this is turning X degrees. Well, if you rotate it again, flip it again, it's going to be rotating the same number of degrees. So if this is X, then from here to here is X. So this would be 2X. So that's why you see this arrow and you see a 2X degrees there. So it is a rotation. And then it's turning about this, that's not the origin, that is point P. So it's turning about P. Alright? And this talks about the degrees again. It says if X is the measure of the acute or right angle formed by K and M, then the angle is a rotation. Then the angle of rotation is going to be 2x to go from this one to the final image. Alright, so let's do some examples. Alright, my first example says that the vertices of ABC are 2, 1, B is 5, 3, C is 6, 2. Find the image of ABC after a glide reflection. Remember, it's going to be a translation and then a reflection. So here's the translation. It's saying that I'm going to be shifting it to the left 8. And then I'm going to reflect it over the x-axis. And then I want to know what are the new coordinates of the image. Okay, so here I'm going to start off with, alright, so this is going to be at 2, 1, and then I'm going to have 5, 3, and 6, 2. This is, you should always use a straight edge or make these lines very straight. This right here is A, this is B, and this is C. This is my original image, that's why these are solid lines. Remember, if you, after the transformation, you make these lines dotted and these have primes. Okay, next I'm going to translate it 8 units to the left. So every single point moves 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. Okay, this is A prime, B prime, C prime. These are dotted. Alright, and I'm not done because now I have to reflect it. So reflecting over the x-axis. So I want equal distance to the x-axis. This is 1 unit, so I want 1 unit down. So this is where my A double prime goes. B is 1, 2, 3 units away from the x-axis, so 3 units in the opposite direction, 1, 2, and 3. This is where your B double prime goes. C is 2 units, then 2 units, so this is where C goes. C double prime. Again, these are dotted. And this one that I'm shading is the final answer. So it says list the coordinates. So A double prime is what I want to list. B double prime and C double prime. A double prime is at -6, -1. B double prime is at -3, -3. And C double prime is at -2, -2. Alright, and so that's how you do a glide reflection. Next, I have the endpoints of CD. The endpoints of CD are at -2, 6, so there's your C, and then my D is at -1, 3. -1, 1, 2, 3, and there's my D. This is a solid line. Okay. Then it says that I have a composition transformation because I'm going to be reflecting it first and then rotating it. Okay, so reflecting over the y-axis, this is the y-axis, that's the first thing I'm going to do. So that's going to be 2 units away, so 2 units this way is going to be my C prime. And then my D prime is 1 unit away, so 1 unit away, there's my D prime. And of course this is dotted. Then my next transformation is a rotation, 90 degrees counterclockwise about the origin. Remember, if they just say rotation, it's always going to be counterclockwise unless it's stated otherwise. I just put this in here for you. But you're always going to be turning counterclockwise unless it's stated. So here, notice how this is in the first quadrant. That means I want to turn it so that it becomes in the second quadrant. So over here, I'm going to list C double prime and D double prime. Where will the new ones be located? Now let's make this one the first quadrant, this is the second quadrant. So C is going to be at 1, 2, 3, 4, 5, 6. -6, +2. And D is going to be at -3, +1. Okay, so turn it back around and graph it. C is at -6, 2, so -6, 1, 2, 3, 4, 5, 6, 1, 2. That's where your C double prime goes. And D double prime is going to be at 1, 2, 3, 1. That's going to be your D double prime. Okay, and there's my composition transformation. All right, now number 3. Number 3 says that in the diagram, a reflection over K maps GF to G prime F prime. Okay, so there's a reflection right here. A reflection over M here takes this one and maps it to the double prime, G prime F prime to G double prime F double prime. So really, moving it all the way over, we know this is going to be a translation. If FA is 6, so this distance right here is 6. Okay, I'm going to highlight that for you. FA is 6, so that's 6. Then I also know that this is going to be 6 because it's the same distance. Reflection is the same distance away from the line of reflection. Then it says DF prime. So here, my DF prime, that's going to be this one here. That's 3. So that means this one's going to be 3. So what I want to do is find the length of G to G double prime. Well, since this forms a parallelogram, we know that this side and this side are going to be congruent. So all I have to do is find the length of this side. So G double prime is going to equal 6 plus 6 plus 3 plus 3. 6 plus 6 plus 3 plus 3, that's going to be 18 units. Okay, next we have in the diagram, the figure is reflected over line K. So here's my original figure. It's going to be reflected over line K. And this here is going to be reflected over line M. Now, remember that these are intersecting, but this is not the origin. These are just two lines that are intersecting, and they tell you that from the distance from here to here, this angle is going to be 80 degrees. So it says describe a single transformation. Well, remember that when it's a reflection and then a reflection, it's just turning. So it's going to turn 80 degrees and then it's going to turn 80 degrees. So here, this is going to be an 80 degree rotation plus an 80 degree rotation, so it's going to be a 160 degree rotation to map F directly to F prime. So to go from here to here, it's going to be 80 plus 80. So 160 degree rotation. And then the rest of it is check for understanding. Notice how they look exactly the same. You have to have this completely done when you come to next class period. And that is it, folks, for notes 9.5.